Hello everyone, welcome to the mechanism sessional tutorial number 5. In this tutorial, we made the wiper mechanism. Our group members are myself, Aniketh, Sridhar 21ME10013, Dudekula Abdul Rasool 21ME10032 and Banoth Sandeep 21MF10042. For this wiper mechanism design, we will be discussing the synthesis of the mechanism, simulation in SOLIDWORKS, displacement analysis, simulation and area wiped in Python, and adding a new idea or innovation, that is increasing the wiper area. Now this mechanism is made according to the tutorial 2's dimensions. Here the dimensions between the ground links is 150 millimeter in vertical sense and 150 millimeter in horizontal sense, and this length AB is 200 mm. Now initially it goes down, it comes up very slowly, and again when it returns back, we can see that it returns quickly back. Now this effect is quick return effect, and we will be optimizing the length and reducing this quick return effect. The original mechanism that was given in the tutorial number 2, without measurements, we had quick return effect. Now to remove this quick return effect, we will be synthesizing the mechanism, the new mechanism basically. Here we can see two extreme positions of the original mechanism. P1, O2 and B2A are the two extreme positions. Corresponding to these extreme positions, we have two positions of P1 and P2. We'll now be joining these two positions by a dotted line. These measurements of P1, O2 and B2A are from the tutorial sheet number 2, where B1A is equal to 80 mm and AO2 is equal to 30 mm. Now our ground O2 will lie on this dotted line so as to avoid any quick return mechanism. For our convenience, we have considered O4, O2 to be 120 mm. BO4 is already 80 mm, AO2 is already 30 mm, and hence we'll get BA as 100 mm. Now we can see that this 4-hour linkage mechanism is satisfying the Grashof criterion. Here 30 plus 120, that is 150, is less than 80 plus 100, which is 180. Therefore, AO2, which is the smallest link, will act as the crank and will rotate in a full circle, and the other mechanism will be rocking. Hence, it's a crank rocker mechanism. Now, for the simulation and designing part, we have used the SolidWorks software. We made a sketch of each link and then extruded it. This is how the sketch looks like. For example, let us take this link. This is the sketch of the link. Then, from the feature, we can extrude this part. Now it is not available because we have already extruded it. After extruding the feature, it looks something like this. From 3D, it looks something like this. The thickness of this extrusion is 2 mm. We made all these parts separately. The ground link, the small crank link, this link AB, the wiper, and then finally we went to the assembly mode. In the assembly mode, we were able to join these parts. Joining these parts was done using the mate feature, which is available here. So here we can see that if we consider the ground link, the mates in the new final file, we can see there is a concentric mate here. This concentric mate is between the ground links circle and this link circle. And we also made a coincident mate, which is nothing but the planes, this plane and the plane of this link, which is to the other side, which is not visible right now, are coincident. And this creates a mate between these two, ground link and the crank link. Similarly, all these mates were made to all the other links. And this is the final mechanism we have obtained. Now we will be simulating the mechanism using the motion analysis feature or the new motion study feature. Now, in the motion study feature, we will be putting a motor here at the crank position. The motor is available here. We can just click on this and select the part where we need to put the motor. We'll be putting it here. So yeah, this is the direction in which the motor is going to turn. Let us have constant speed and the RPM is set to 10 and click on OK. Now let us run the mechanism. This is how the mechanism runs. We can see how smoothly it is running. There is no quick return effect and the area traced is clearly visible. Now let us analyze the velocities. For the velocity analysis, we shall be using the results or plots. The plot of the linear velocity. We have already made the plot here. We can get that by using this feature, plots and results. Let us show the plot. This is the plot of the velocity profile. We can see that the plot is symmetrical about this axis. This tells us that there is no quick return mechanism. We can see that the plot is symmetrical about this axis. So this shows that the mechanism here has no quick return effect. Let us try to run it once more. We can see that, there is no quick return effect as it is going back. It is symmetrical.
Hello, my name is Abdul Rasool. Okay, let's do the displacement analysis. Let L1, L2, L3, L4 are the lengths of these given links, and theta 2, theta 3, theta 4 are the angles made by these links with x-axis. If the lengths of all these links are fixed, and if there is a particular angle theta 2, then the mechanism is fixed. It should have particular position, because this 4-hour mechanism has only 1 degree of freedom. So for a given input angle theta 2, we have to find the output angles theta 4, theta 3. So by using displacement analysis, we will get these two relations from the mechanism. Here, if we eliminate theta 3, we will get a equation to find out the theta 4. We can write this equation in the form of a sin theta 4 plus b cos theta 4 is equal to c, where a, b, c are the constants which depends on input length and input angle theta 2. So if we solve for theta 4, we will get this expression. We can find theta 4 from this expression. We may get another value of theta 4, but here only one value is shown, which is corresponding to our desired mechanism. Once we find out theta 4, we can find out theta 3 using this expression. So for a given input angle theta 2, we can find the output angles theta 4 and theta 3 using these two expressions. We have done the Viper mechanism simulation in Python as well. Here, we give the lengths of all links which we obtain from the synthesis as discussed by my teammate Aniketh, and we set number of rotations is equal to 5 for which we are going to simulate. Coming to the input angles, the input angles theta 2 are given between regular intervals from between 0 to up to 5 rotations. So here, for each value of theta 2, we have to find the value of theta 4, and we will do that by using the expression which we got from the displacement analysis. So this is the code from which we can find out the value of theta 4. So for each value of input theta 2, derivate output value for theta 4. Here we can see the minimum and maximum angle the rocker makes with the x-axis, which is the minimum angle is 23 degrees and the maximum angle is 67 degrees. Now we have to set some deviation between Viper and rocker so that the Viper wipes symmetrically from the point where it placed, and we found that deviation is to be 44 degrees. So the Viper has set to be 44 degrees deviated from the rocker. So for the deviation of 44 degrees, we find the output angles for the Viper, which is theta 5 for each value of the input angle theta 2. We also find the value of theta 3 from the expression which we got from the displacement analysis. So we will plot all the points and we simulate it. Let's see the simulation. So here we can see the area wiped by the Viper, and we can see that it is symmetric about this point. It's because we have set the deviation between this rocker and the Viper. We can calculate the area wiped by this Viper. We calculated the area and it comes out to be 46,145 millimeters square.
Now, for the new idea/innovation that we have introduced into this mechanism, we wanted to increase the wiping area. For that purpose, we increase the crank length. Here the crank length we can see in green color is 50 mm, whereas here it is only 30 mm. Now let us run the animation and see how the area wiped changes with the crank length. Here, these two are the velocity plots of this point and this point. This plot corresponds to this mechanism and this point corresponds to this mechanism, that is 50 mm and this is 30 mm. Let us see the animation. It is very clear from the animation that with increase in crank length, the wiped area is increasing. Thank you everyone for watching our video.